What is inertia? It is the natural propensity of a body to resist the change of its state of rest, if it is at rest, or rectilinear uniform motion, when acted upon by an applied force, under the conditions provided by Newton's second and third laws of motion. Acceleration, being a change in that natural tendency, always requires an applied force. Since forces are produced in pairs of equal and opposite components, two interacting bodies are also required to obtain the acceleration. Newton's third law. Acceleration also implies opposition, or a conflict between the inertial tendencies of the two bodies in interaction. Inertial tendencies, just to remember, are the property of all bodies to stay at rest, or uniform motion in a straight line, when free of applied forces. In the acceleration process, the inertial tendencies of the two bodies in interaction are thwarted. That is, their speed changes or the direction of motion changes, or both. Newton described inertia in the definition 3 of the section definitions of the book 1 of his major work, The Mathematical Principles of Natural Philosophy. The definition 3 states that the vis insita, or innate force of matter, is a power of resisting, by which every body, as much as in it lies, endeavors to persevere in its present state, whether it be of rest, or of moving uniformly forward in a right line. A body free of any applied forces maintains its state of rest or rectilinear motion as a fundamental tendency. It is certain, therefore, that a body not interacting with another body is free of applied forces, because interaction means two bodies acted upon by a pair of equal and opposite forces, causing their acceleration. Newton added a commentary to the definition 3 to explain his view about how inertia is manifested. The commentary is here divided in two parts. Part 1 refers to his definition of inertia. Part 2 refers to how inertia is manifested. Commentary to the definition 3. Part 1. This force is ever proportional to the body whose force it is, and differs nothing from the inactivity of the mass, but in our manner of conceiving it. A body, from the inactivity of matter, is not without difficulty put out of its state of rest or motion. Upon which account, this vis insita may, by a most significant name, be called vis inertiae, or force of inactivity. It should be noted that, after Newton, the development of rigid body mechanics focused primarily on the second law of motion, given the need to calculate the behavior of the bodies in terms of mass forces and acceleration, implicitly assuming the third law as a redundancy. The idea of inertia as an innate resistive force, taken together with the second law, led to the D'Alembert's principle. When a body is acted upon by an applied force, it reacts, manifesting a force of inertia equal and opposite. Since this concept was considered with the second law isolated from the other laws of motion, it followed that the force of inertia is manifested by the body upon itself, as a self-force. Inertia, as a self-force, has never been empirically demonstrated. In addition, a force of inertia manifested by the body upon itself, being equal and opposite to the applied force, should prevent the body to be accelerated. Since the body is effectively accelerated, this so-called force of inertia was later called fictitious force. Fictitious forces are no forces at all. It is, however, impossible to accelerate a body employing the second law of motion only. Forces are always produced in pairs of equal and opposite components. When a force produces the acceleration of a body, its counterpart must act upon another body, connected to the former, producing its opposite acceleration. This represents the symmetry of all acceleration processes. To accelerate a body, the following conditions must be met. First, a pair of two connected bodies is required. Second, a pair of equal and opposite applied forces is also required. Third, the two bodies must resist acceleration. The resistance of each body acts upon the other, reciprocally. The inertial resistance is a key condition for acceleration. If one of the bodies of the pair didn't resist the action of the applied force, it would move with infinite acceleration, and the other would not accelerate, as figured out by Kepler. Therefore, The inertial resistance to acceleration is not manifested by the body upon itself, as a fictitious self-force, but upon the other interacting body of the system, reciprocally, as a real force. Since the bodies are able to resist acceleration, they must have a natural propensity to differentiate between acceleration and non-acceleration. Newton's commentary to the definition 3, part 2. But a body exerts this force only when another force, impressed upon it, endeavors to change its condition, and the exercise of this force may be considered both as resistance and impulse. It is resistance, insofar as the body, for maintaining its present state, withstands the force impressed. It is impulse, insofar as the body, by not easily giving way to the impressed force of another, endeavors to change the state of that other. This part 2 of his commentary suggests that Newton was taking into account the conditions provided by the third law of motion. The conflict between the inertial resistances of two interacting bodies, under the action of a pair of equal and opposite applied forces, is called, in this video series, inertial confrontation. And both inertial tendencies of the bodies are thwarted in the process, which supports their reciprocal opposite accelerations, in accordance with the third law of motion. The previous commentary to the definition 3, written by Newton in the Principia, is the underlying mechanism of all acceleration processes, which imply the application of the three laws of motion together. When a force provider applies a force upon a body A, he applies, simultaneously, a force upon another connected body B. It is the inertial resistance of the body A, which allows the force provider to apply a force upon the body B. At the same time, it is the inertial resistance of the body B, which allows the force provider to apply a force upon the body A. This now clear linear acceleration mechanism is the same as that for curvilinear motions, and especially for the motion resulting from the unbalanced rotation.